Oh, hello. Didn't see you there. I was just busy playing this cool game that I'm making called Breakout. Well, it's a clone of Breakout. Uh, Someone else already made a game called Breakout. We'll have to come up with our own name for it some other time. Uh, Maybe Break Free, Bust Free, Get Loose. I don't know. So you can see where we are right now. There's some kind of physics going on. Obviously a whole lot of jank, but we do have collision detection with the ball against the bricks, and with the ball against the paddle, and with this against the sides of the playing field. We are loading the playing field or the stage data from a sort of definition of it in memory in ROM. But the big problem right now, the big thing right now that is making this not a game that you can play is that instead of breaking the bricks, the ball just bounces right off of them. So we need to do that. And the reason why I didn't go ahead and do that straight away is that's going to involve drawing to the screen. And on the Game Boy, something like 99% of the time, you cannot touch video memory. You cannot touch the screen data because the Game Boy is using that to update the display. The Game Boy gives you an extremely short window of time called V-blank, during which time you can hi Nelly. Sorry, I'm getting distracted by my cat. Gives you a very short window of time called V-blank when you are allowed to update memory, or video memory. So what we need to do is we need to tell the we need to while we're running the game. While we're running the game, the screen is being drawn by the Game Boy and we're not allowed to touch the video memory. So we need to queue up some updates for it. And then once V-blank hits, which we wait for at the end of every frame of updating the game state, we take that opportunity to do these updates. And notably, we can't just redraw the entire board during V-blank because V-blank is such a short window of time that we just don't have the time. What'll end up happening is that our I have a camera Nelly. What'll end up happening is that as we try to redraw the board during V-blank, we'll run out of time, V-blank will end, and then any attempt to write to video memory is just ignored. The CPU is locked out of it. So we'll end up with a half-updated game board, which we don't want. So let's get to this, okay? So we are going to do a couple of things here. Instead of reflecting off of the brick, well, we actually do still want to reflect off of the brick. But what we also want to do is we want to clear the brick easy peasy. That just this is in our collision code, and we had an HL pointer to the stage data in memory. So we want to clear that brick out. We are going to want to reflect. But what we're also going to need to do is queue some kind of update, like I said, for video memory. And then we have, right now it's just in the main file, the main like breakout.asm file. We've got this vblank routine. And right now all the vblank routine does is update the state of the sprites. But we're going to need to put some code in here to erase any destroyed bricks. And we're going to need to put in here this. Does that make sense? Probably not, but whatever, it's fine. Today is going to be hopefully a nice, chill, kind of loosey-goosey session. I'm drinking delicious Tofino kombucha. I'm not being sponsored for this, freaking obviously. I like kombucha an awful lot. This is really good. I'm just trying this for the first time. I got it from the grocery store this morning. And I'm into it. Tofino is a beautiful town on the west coast of Vancouver Island, where I live. It is basically the end of the Western world, effectively. It's really a remarkable place. It's a big surfing destination. If you're into surfing, I'm not, but this is what I've been told. It's real close to Pacific Rim National Park. Just a lovely, lovely place. So, let's create some variables for our vblank routine where we're going to store this update. And I'm trying to think. It's probably not possible for you to destroy more than one brick during any given frame. It's like sort of hypothetically possible that we're going to be doing a check on the y-axis and then on the x-axis. So it's sort of hypothetically possible, but I'm not sure if in practice it is. And you know, if I were using like a modern programming language, writing this code for like a modern computer, which has all the memory and abstractions and amenities I could possibly want, I would just create a list of updates. But since I'm not, and doing things like lists is like annoying on the Game Boy, I might just only allow for one possible update. And we'll see how this goes. If it turns out that we're going to want multiple updates to VRAM, I will probably set up some sort of system where we can queue multiple updates. But for now, just being able to say, do we have an update? We do. It's this byte at this address. That's all I'm going to do. And if that proves sufficient, great. If not, we'll do something a little more elaborate. So these are going to be public on account of we're going to be hitting them from ball.asm. And eventually I'm probably going to put this vblank code in like a vblank.asm, but for now let's leave it at this. Let's write this code. VBlank code needs to be really, really fast. Like, it's actually probably a dumb and bad idea that I am even having this as a procedure call instead of just embedding it right inside the VBlank code. But Breakout is a simple enough game that it's probably fine, but if I wanted to do stuff like stream in new sprites for animation or stream in new map data to allow for like an infinite scroll, like it becomes like really, really crucial to just have like the absolute bare minimum of code running during VBlank. But for now, I'm not going to worry about micro-optimizing it until it's necessary. Like I might do something like even, take for granted the fact that these were all linear in memory, so I can load everything really, really quickly. There's all sorts of opportunities for micro-optimizing your VBlank routine. I once disassembled the Donkey Kong Land VBlank routine. Donkey Kong Land, very impressive looking game for the Game Boy. At least technically speaking. It's actually kind of ugly because they did the Donkey Kong Country thing and computer animated all the graphics, which looked awesome on the Super Nintendo and terrible on the Game Boy where you only had 4 colors, like black and white, 4 shades of green. So it kind of looks terrible, but it's very technically impressive. And they do manage to like stream in new map data and stream in sprites for animation every frame, which is kind of incredible. And the sorts of optimizations they do are just bananas. They take advantage of this Game Boy stack instructions to push data onto the stack as a way of writing to VRAM. They relocate the stack pointer into VRAM and then push onto the stack to write into VRAM. It's pretty damn clever. So the first thing we do is we just check to see if we need to update VRAM. If not, we return. And I'm going to just put the end of the function here. Or like even this is kind of, so you can see what I'm doing here is I'm like clearing, this should be x already set to 0. I'm clearing the VBlank or VRAM update needed variable in my VBlank routine, even though we still have more work to do afterwards. And arguably, that's a terrible idea. Like, arguably, I should stick that right at the end, so that way, because this variable is not in VRAM, so we can update it whenever. We might as well do it after the fact. Actually, I'm gonna, talking it through, I'm just like, I'm gonna do that right now. And then I'm actually going to, instead of calling this procedure every time, I'm going to call it conditionally. I still need to run VBlank update. So all we're going to do is we're going to get the VRAM update address and put it into HL. And then we are going to get the VRAM update data. All we have to do really is write it. Nice and easy. And hopefully this will just do what we need it to do. And I will need to, let's see here. Initialize that variable before I do anything. This is just to make sure that I haven't broken anything yet. Yeah. Everything still works exactly the way it did before. So now we've got this means by which we can update VRAM. So now we need to do this. We need to queue the update. So what are some things we're going to need to do? We're going to need to set the flag, indicate that we have an update to do, and we need to do that last in the unlikely event that if we set up the update here, there would be an unlikely instance in which vblank could trigger in between this flag being set and the update being set up. And then really bad things would happen because we'd go to do the update, but we'd be using garbage data, and then the update itself wouldn't actually end up getting run. So we need to set up the update before we set the flag. Okay. So now we're clearing the tile. So that next part is setting the data is easy. We call it vblank update data. The hard part is going to be getting this address. And you can see this function is starting to get pretty ungainly. So once we're done this, I'm going to start refactoring it. But we need to get the address that we need to clear. And notably, this isn't the address from the stage data. It is going to be translated quite a bit. To the point where it might actually be easier to just recalculate it. A little bit wasteful, but I think that's what we're going to do. We're going to recalculate it. And that'll be less egregious once everything is like put into nice separate procedures. it'll look less egregious anyways. So again, we get the do we want to recalculate it? Maybe it would be better to translate from the might be better to translate from the offset, right? Because so H is, so all we need to do is translate from L. So L indicates the offset into the stage map data. We need to translate that into an offset into the tile data. So if we look here, where am I mapped to? Okay, the map, yeah. So here L equals 0. Yeah, L equals 0, but the map address is 9842. So how do we account for that? Well, first of all, I'm going to write this in like high-level code. And translate it after the fact. Update address equals 9800 plus map offset divided by map width. That gets the row. So let me actually break it up even more. VRAM row offset equals VRAM row times 32. Each one of these is 32 tiles across. So that's hex 20 decimal 32. Actually, I'm just going to call that row. Call equals map offset mod map width. And then call offset equals call. This is a lot simpler. We start drawing 2 tiles in, so it's just +2. So that's how we're going to compute this at the end of the day. It's not going to be a ton of fun because we're going to have some 16-bit arithmetic. But we'll get it done. Okay. So. And it is frustrating because we did actually get the row up here, but I'm just going to redo this work a little bit. So to divide by the map width, well, all we have to do is swap A. That's a division by 16. Now to multiply by 32, we have to do swap A again. So we can actually, we will be able to just optimize this by getting rid of these swap instructions. And then we want to shift left again. And, okay. So this is actually going to be pretty nice. So C add HMBC. So I think do I actually want to bother using 16-bit arithmetic for this, or do I want to just Oh, questions. Yeah, thinking about this is hard. There's a lot to think about. It might actually be worth storing this in memory, like running a procedure to store this in memory, so that way we can reuse it easily. I don't know. Ugh. This is the good stuff right here. This is this is to handle my bit. Be less educational this session and more me slamming my head against the desk and sweating profusely as I embarrass myself in front of my audience of thousands. Because yeah, the problem is that I'm starting to get like having a hard time keeping track of everything going on and like figuring out how to allocate where to put everything in registers, and cleanly preserving it, because like we need to keep this map offset going. And we have it in L right now, but we're going to want to put our destination in L, our VRAM destination in L. So then, like, we need to find another temporary register to store it, and it's just going to be hard to keep everything in mind. So that's why I'm kind of getting antsy. And like we could put it in DE instead. That would work. But then we can't do the 16-bit arithmetic. And maybe we don't want to do the 16-bit arithmetic because maybe we can just simulate it using the 8-bit arithmetic. Yeah, Nelly. I agree. Do you want to come up? Do you want to help me program, Nelly? Do you want to be my rubber ducky? It's often said that a good way to solve a problem when you're a programmer is to keep a rubber duck on your desk and explain the problem to the rubber duck, and by talking it through, trying to explain it, the solution will come to you. Yeah? What's the matter? Oh, do you want cuddles? Totally wants cuddles. This is why I've never been productive working from home, is because I always get distracted by my cat. This whole COVID thing has been real hard for me productivity-wise because I just spend all day petting my cat. Hey, baby. Are you adorable? You're freaking adorable. The most freaking adorable baby there is. Oh my gosh. I don't know how well you can see this, but her head is just like pointed directly up at my face. She's giving me some real love eyes. It's absolutely wonderful to get a cat if you don't have a cat. If you learn nothing from this stream about how to program games, at least you can learn that cats are amazing. You need a cat. Okay, so yeah, I think that's what I'm going to do. I'm going to use DE instead. A nice natural destination register. I'm going to take the offset. I'm going to shift it to the left. Or is that right? Can I just shift it to the left? No, I need to actually. Right, I need to hand out the lower bit. Which is effectively the same thing as dividing by 16 and then multiplying by 16. Again, because when you divide by 16, anything that's not divisible by 16 is just going to get truncated off, and we're doing this sort of integer arithmetic. So we're going to do that. Then we are going to load that result into E. So actually we don't need to, we can just do that slightly faster. And then we're going to, if there's no carry, we're going to, then if doing that shift pushed something up in the top bit off, we're going to increment D, and that's going to be like the equivalent of like a 16-bit shift or whatever. So that way we can avoid any sort of 16-bit arithmetic. So now DE is going to contain the row offset that we want. Oh, but we might be off by, we might need to add 2 to it. Is the only thing. think we want to add 2 here. I'm going to go back and comment the heck out of this because this is getting super sketchy. And then we're going to get that column offset again. Sorry, we're going to get the offset into the stage map again. And this time we're going to sort of do the opposite. We're going to take the mod 32. So that means we just chop off the top the top 3 bits. Right, because if you want to see if something is like the mod 2, you chop off everything but the lowest bit. If you want mod 4, 8, 16, 32. So we're going to chop everything off except for that. Then we're going to add 2 again to account for the fact that we start drawing 2 tiles in. We're going to add that to E. There we go. And then we're going to set that as our update address. There we go. I'm sorry if that was kind of hard to grok as I figured out in real time exactly what I needed to do. And of course I'm completely jumping the gun here because I'm assuming that this works, which is a real assumption. VBlank update, oh I called it VRAM update needed, and VRAM update address. And all that. There we go. Well, let's see how calamitous this was. I mean, it doesn't work, but oh yeah, there we go. So clearly there's something really wrong with our computation, but you can at least see it in action. Oh dear, okay. Let's step through this with the most basic case, the 42. So suppose L equals 42, right? So we're going to get that. If we do this and, L is now going to equal 2, which is that correct? I mean, oh, but it's not going to be 42. If it's 0, let's start with 0. 0 is always a great case. Yeah, and then we do want to, because we're 2 tiles in, so we want to get 42 at the end. So we're 2 tiles in. We are going to shift that left. We're still going to get, then we're going to get 4, which is correct. We're going to load that into E. We're going to skip this increment because we didn't cause a carry. We're going to go get that 0 again. We'll clear out some stuff. Well, that's not going to do anything. We're going to add 2. And then we're going to add E, which E was E was 4. This seems like it might be the problem. This is the problem. We're not computing this right. The intention here is to Right, the intention here is to multiply by 32. And that is not at all what we're doing. Um, hmm. Is this going to work? This seems sketch. Okay. Let's go with 1. Let's say that yeah, let's use 1 instead as our example, so that way I can make sure my math isn't off. So we want to get 62 at the end, and we equal. So let's say I'm going to annotate this. Assume L equals 16. So we want to, the first thing we want to do is we want to end up with we want to get the row. So we're going to do this, and we're going to get, yeah, okay. So then we're still going to have 16. Then we're going to have 32. We're going to get having done this, A is going to equal 20. Oh, God, what did I do? I screwed this up. Let me go back to where things were before. And redo. This is where we compiled and where things weren't working. So we're going to start and we're going to say L equals 16. Now A equals 16. A still equals 16 after that and. Now A is going to equal 12. A is going to equal 18. And that's completely wrong. Yeah, we don't want A to equal. We want A to equal 48, I believe, or maybe even. This is getting dicey. Right. So this is as though we. This is as though we have. This is what is going on. Yeah, we want to add 20 here. And what that's doing is that is effectively adding 2 rows to the row count. The row right now is in the upper nibble. So we do this, and now A equals 30. And we do this, and A is going to equal 60. We've doubled it, which is what we want. Yeah, okay. I think that was the problem. I was adding the offset for the row in the wrong location. So I'm going to rebuild. That's what happened when I undo too much. There we go. Let's see if this fixes things. If this doesn't work, I might have to. Oh, it still doesn't work. Why doesn't it work? Oh no. So it sort of is starting to work. Like that sort of worked. The problem is that it looks like there might be some sort of issue with rounding, or not rounding, but like overflow. Like it seems to work for the upper rows, but not for the lower rows. Yes, Nellie? Yeah? Oh, no. Really? I see. Yeah. I'm so sorry. Oh, baby. Okay. So let's try to think about this. Why would this not be working here? Let's look at something like this. This is row 1, 2, 3, 4, 5, 6, 7. Okay, so this is 0 to 7. This is row 7. For simplicity's sake, I'm going to pretend as though it's the leftmost brick instead. So let's start with L equals row 7, which is going to equal 70. Yes, Nellie? Uh-huh. Okay. There we go. There's a good cat. Hi, baby. Yeah. So unproductive. Yeah? Did you want me to... Are you mad because I stopped petting you as aggressively? Oh my gosh. Okay. And then the actual tile that we want to get at the end here is 9922. So now A equals 70. Now here A is going to equal 90. And this is going to trigger that overflow that I was talking about. So just to illustrate exactly what happened, I'm going to pop open a calculator. I'm going to switch to programmer mode. We're going to switch to hex, and we're going to hit 90, and I'm going to shift left once. And you're going to see in hex, A is now going to equal 20. And now we've got this high nibble here, or the higher byte, and now that's set to 1. So A is going to equal 20. So E is going to equal 20. And now D is going to equal 99. So what we have here should be 9920. And what's the tile that we actually want? 9922. So that looks like it should be correct. We get this L again. The L is yeah, that really looks like it should be correct. Stepping through it and everything. All right. Time for things to get really, really serious. One thing that I haven't done is that I haven't generated a map file. I should probably generate a map file. Which I think that's done by the linker. What other stuff should I do? I'm gonna let's make some changes here. So first of all, we are in DMG mode. Second of all, I want to generate a map file. I, for the life of me, have never managed to generate a symbol file. So okay, it doesn't even work anymore. So okay. Wait, what? -N. Maybe I'll try that now. breakout.map-n breakout.sim. So I'm going to do that. I'm going to reload the ROM. Oh wow, it just worked. That's awesome. I'm going to try to find. Um, you only have addresses. Can I search for? Uh, what did I call it? I called it. Oh, it's in ball. Check stage collide. Can I just go to it? Nice, I totally can. Okay, so I'm going to set a breakpoint here. And we're just going to step right through the code to see if we can figure out what's going on. And I'm going to try to just hit, that. Perfect. Okay, so you can see L here is 73. So even this seems to be slightly off because what L really should be here is I think 70. So something is wrong there for starters, but never mind that. So we get that 73. We clear out the bottom bit. We're at 90. We shift left. We're at 20. We load that into there. Increment D. Very nice. Oh, and this is totally off too. That computation seems to be off. Because we should be getting 3 here, not... I think maybe we want... I think I got this wrong. And we want that. Right, because it's not... We don't want mod 32, we want mod 16 because the map is 16 tiles wide, not 32 tiles wide. There's the problem, or a problem. Let's rebuild. Let's reload. Let's clear that breakpoint, I think. Let's see how this looks. I'd say this looks pretty damn good. That's what I would say. There we go. Ugh, I was getting really worried there. That probably, these videos and streams are meant to show the whole process, and that includes lots of frustration and angst, and that's just what it is. But I was starting to feel like I was coming out looking not so great there. I probably did, but in the end, just a couple of minor little tweaks were involved. You got to see me using BGB's debugger. There we go. That's what I was going for. Everyone came out learning something. So now let me, I'm going to commit this change, and then we're going to fix the way that it doesn't do any collision on the left and right. So first thing I'm going to do is just those changes where I generated a map and a symbol file. I'm going to commit. And those are things that we don't want to include. Those are just builder effects. We don't want to include those in our Git history. So I'm going to commit that. So if you're curious, actually, I don't think I explained this at all. The symbol file is what allows BGB to know that these addresses correspond to things like paddle X and VBlank and move right and so on, so that we can actually see those in the debugger instead of just numbers. And the map file is, shoot, that wasn't on screen. The map file tells us where everything has been put into memory. It tells us, one of my favorite features is it tells us how much space we have left in places. which is very useful when you start getting really down to the wire, memory-wise. Okay, so having done that, what do we need to do next? I'm going to just put the VRAM update code in a commit. And then I'm probably just going to put all of the code to, all of this into a commit. Oh, I need to clean this up a little bit. I get rid of my debugging annotations. I mean, the code itself I seriously need to clean up. This is completely unreadable. And arguably part of why I had so much trouble figuring out what the bug was. But anyways, I'll do that in a follow-up commit. So even though this, like I said, this really needs to be cleaned up very, very badly. I am going to just copy and paste it because it's going to be very, very similar for the x-axis. Like all of this is going to stay the same, so I really, really need to find a way to reuse this. There's only two differences. One, we're going to, actually there's only one difference. We're going to reflect along the x-axis, and we're going to call it as part of the, so this is a disaster code maintenance-wise. Definitely going to fix this. We're going to call it over here. Hopefully it just builds, and hopefully this does what we want, although I really need to, like I keep saying, I need to clean it up. So let's try to get it in between these things. Yeah, there we go. You can see this actually looks, starting to look the way like a breakout game should look. I mean, that's pretty much the way a breakout game should look. So we're really close to having an actual game now, which is awesome. I screwed that up, I think. These should go in the previous commit. And then there we go. Okay. I guess the cleanup here is what I want to do. So what things need? So first of all, I think I just want to have a what do I want to have? How do I want to do this? I think what I probably want to do is start breaking this down. So I'm going to put yeah, it's hard. It's hard to know exactly what where the right place is to cut things up, especially because I like doing these things imperatively. So what I'm going to do, I'm going to actually just take a very quick break while I go get something to drink. And hopefully in that time I will have been able to give this a little bit of thought, and we can get back to it. All right, BRB. Okay. Um, right. So I gave it some thought. I cogitated a little bit over the course of the past 2 minutes. Oh, Nelly. What's the matter, Nelly? Why are you so cranky today? Oh, yeah. Gosh, I love my cat. So one problem we have here is that we're recomputing the ball's position. Which is really, really silly. So let's break this up. Well, I mean, it's not really, really silly. We actually have to do it. I take it back. Because the whole point is we apply the y velocity. We check to see if the ball's position has entered has entered a new tile. And if it has, we run the collision code. But nevertheless, like, it doesn't make sense. We can get the row. and store that as part of the y movement. And then all we need to do is get the new x position, for example. So that's what I'm going to do. I'm going to have I'm just going to put these into memory. And like I said, because the x velocity isn't going to affect what row we are in, we don't need to recompute this. We do need to recompute the column, but I'm going to do that. I'm going to do that before we call check stage collide x. Row. And likewise, applying the y velocity isn't going to affect what column we're in, so we can just do that there. I just need to make sure I initialize everything properly. So, okay, so then inbounds. Okay. So that's not huge. That's a pretty minor improvement, but it is an improvement. The only other thing is we are going to need to, actually, I don't think we do even need to initialize that. I think we're probably fine not initializing it because we're always going to run that update code before we run any collision code. So let's see if this works okay. Sure seems to work okay as far as I can tell, which is great. So having done that, let's save that minor improvement. I'm not even sure if I want to touch any of this, actually. like this is duplicated, which is unfortunate, but it's, the problem is that I don't want to start like trying to deal with figuring out how to pass flags back and forth if like I added another thing which was like call check stage collide, then it's like, do I use a flag and I like, even though this really is an awful lot of duplication, maybe that is the right thing to do, to have like a collide flag or something. Or to put it, because there's all these different ways in which we can return. I'm going to leave this duplicated for now because it's like straightforward and easy to follow. Not a fan of it exactly. Yeah, maybe let's do that. I take it back. I'm going to have a thing called collide flag. But then, you know, the other thing is we're preserving HL. We're using the HL that we computed in order to figure out whether we collided or not. And on top of that, I can't just really easily compute the HL because it's possible that the HL is the offset into the stage map. And there isn't always a valid offset into the stage map. So I could have another separate flag, which is like, oh, is this an invalid offset? Is this a valid offset? I mean, you know, this is sort of the complex. There's just a lot of logic that's kind of like pieced together. Okay. That's what I can do. I can start unpeeling this logic. I'm gonna have a thing for like, which is like check ball inbounds. And I am going to be sacrificing some performance here, but I think it's going to be worth it to make just everything a whole lot easier to follow. So I hate these sorts of conventions because they're really not obvious, but we're going to say sets and let's see if inbounds see otherwise. But that is pretty straightforward. So what we're going to do is we're going to first, we're just going to call check ball inbounds. And we're going to return if we're not in bounds. And then we just don't need to even think about this inbounds stuff at all as part of the collision logic. So yeah, I'm going to do that over here. And again, that just is like this light simplification that is going to make this code easier to follow. Yeah? Yeah? Yeah. Whoop. Up we go. Okay. So once again, let's build it and make sure that everything is a-okay. Let me get rid of that for now. I didn't actually end up using that. Oh, uh-oh. Reading uninitialized W. I would think that there's no way that that could be the case yet. Ball row and ball call should have been set. Let me look at my diff now. Because the only change that got made here was that previously check stage Clyde X got the ball row, and now the first thing it does is call check ball and bounds, which it just gets the row. Same deal with check stage Clyde Y. I don't understand how this change could have caused that. Well, that isn't check stage Collide X that this is happening. And it is true that check stage Collide X is called in update ball X, which only updates the ball column. Oh, that's the problem, or a problem. Never actually. I'm surprised this didn't run into issues before. It's bizarre, frankly. Update ball row. Yeah, and that's called an update ball Y, which is called first. No, update ball X is called before update ball Y. Either way, we should initialize them. I mean, that's sort of a fundamental problem. Oh, don't make me do this computation. I'm honestly just going to set these to 0, and that is wrong, but it'll work out okay. Because we'll fix them on the first frame, which is not great, but probably won't cause any issues and will spare me from like needing to think about what the actual correct values for these are. Yeah, okay. Oh, whoops, I want to reload, because, yeah. Well, aside from the fact that we seem to instantaneously destroy the first this brick, we seem to just spontaneously instantly destroy it. It seems to be working okay. That is probably a side effect of me not properly initializing these things. Honestly, if I set these to just out of bounds, this will also probably work. Because they'll be out of bounds. Reload. Yeah, that worked. Super hacky, but gets the job done. So let me fix those issues. Fix those issues, which really should have gone in the previous commit. I'm not sure how I didn't catch that actually, or how it worked when it did. And the other thing, where was the other thing that I had done? The other thing I had done is separately factored out the check ball and bounds. Bounds check. Yeah, and then the next thing I want to do is probably something similar. Check stage collide, factor that out. So what does that do? That just takes the current position. It's going to do something similar. It's going to set a flag based on whether there's a collision or not. It sets. Oh god, I'm so used to Emacs. I press Control K, which is the Emacs keystroke for clearing to the end of the line. And so this is going to continue working. We're going to call check stage collide. The unfortunate thing right now is that we're relying on stop relying on HL. So we're relying on the value that we computed in HL here, which sucks. And actually, now that we're storing the ball row and the ball column, we can probably make this a whole lot, we can probably make the math a lot simpler. So we can make this better anyways. So once again, to delete all of this. Fingers crossed this will just work. Let me have a quick look at this. Yeah, that looks good. Okay. Let me reload. Still seems to work okay. Awesome. Okay, so next, let's save that again as a commit. Finally, what we're going to do is I'm going to take all of this out, and I'm going to be I'm going to call this like clear colliding block. So, and then I'm going to rewrite this quite a bit. because unfortunately it's that sucks. It sucks. So we've computed the tile. Maybe we shouldn't stop relying on HL. Okay, yeah, I'm actually maybe not going to stop relying on HL. I do wonder if computing this fresh from the row and the column would be, I think it'll be easier to understand. So I might do that, but I don't want to compute the stage pointer and then compute it again for no good reason. Even if I could like factor that out, like I just, and maybe there'll come a point where it will make sense to factor it out and recompute it. But right now I'm going to just leave that as is. But I am going to rewrite this to use ball row and ball call. I believe, but in a separate commit. There we go. Still working great. So next, let's save that as a commit. And yeah, instead of doing this, so I think that's just like a little bit easier to read. We might be losing a tiny bit of performance, but it's going to be easier to read. And if there comes a time that we want to start, factoring this code out even more for one reason or another, there's like no longer this dependency from all of this code on HL that is used here. So we'll be able to rip this out and do it separately. So I think that is a slight improvement maintainability-wise. Hopefully I didn't break anything, but it seems to be good so far. So there we go, and we're at an hour and 24 minutes or so, I mean we've come so far over the course of the past 90 minutes. So I think it's definitely time to take a breather. We're almost at the point where we've got an actual game going, which is awesome. We just need to do things like lives, a win condition, a game over condition, and then I think I won't say that we're done by any means. I want to really try to turn this into a really polished product, but we are definitely going to be at the point where I might cut an alpha or something like that so that people can play this. I might try testing it on my real hardware and stuff like that, I suspect it'll work just fine. BGB is very accurate, and I haven't done anything particularly fancy. One thing that I do love is that you can see this green monitor here shows how much of the Game Boy CPU we're using, and we are using like none of it. You can see it's for all, despite all this collision detection code, and that's awesome because on the Game Boy, the more CPU you use, the more battery you use. So like it's very important not to peg the CPU, and it's a real coder pride to keep everything nice and light. So even though we're not doing anything crazy or anything like that, it's still really a nice sign. We can do as much as we're doing without any issues. Anyways, sorry. So I guess tomorrow what we're going to do is I'm going to start implementing, like I said, things to turn this into an actual game. Lives, game over, and like some kind of win condition, even if the win condition is just, it starts over once you've cleared everything. But anyways, thank you so much for watching. Take it easy. Have a good rest of your Thursday if you're watching this live, or if you're watching this on YouTube after the fact, have a good rest of your day. And please tune in the future for the continuation of this development. Yeah. Peace. I'm out.